Okay, for 1a and b, they want us to use DeMoivres Theorem here to find the indicated power and write our answer back in standard form a plus bi. So I'm just going to apply the rule. This is 1 to the third kiss, and then 3 times the angle, pi over 4. So let's see, that's a radius of just 1, so I have 1 kiss and 3 pi over 4. So I just need to convert this now. So I'm going to do cosine of 3 pi over 4, that's a negative square root of 2 over 2. Sine of 3 pi over 4 is a positive square root of 2 over 2, I. And that is the answer. Two ways of doing that. The way I just did it, where I literally evaluated what cosine is and sine is. You could also graph it if you're a little bit more visual and try to recreate this triangle here, that this is a 45, and what the side lengths would be when you do that. Over here, the first thing we need to do is actually put this in put this in trig form. So I can plot this, it's 1 and 1. I recognize this as being a square root of 2 and a 45. So I'm going to rewrite this as square root of 2 kiss pi over 4 raised to the 5th. Okay? So that's going to become the square root of 2 to the 5th kiss 5 pi over 4. And now we just need to simplify this a little bit. So I'm going to have square root of 2 to the 5th cosine of 5 pi over 4. That's going to be a negative square root of 2 over 2. Plus square root of 2 to the 5th times sine. That's also a negative square root of 2 over 2, I. And we can actually simplify this a little bit. If we do square root of 2 to the 5th times another square root of 2, that's actually going to just give us 8, I believe, right? We'll have square root of 2 to the 6th. If we rewrite that, that's 2 to the 6 over 2. So that's 2 to the 3rd, which is 8. So we get 8 over 2. That was negative. Plus, we'll get the same thing over here, an 8 over 2i. So this is going to actually just be negative 4 minus 4i. For 2a and b, they just want us to find the cube root of the complex number. Okay, so we're going to be using this formula over here. First thing I'm going to do actually is just rewrite this as 0, because that's what its coterminal angle is. That makes our life significantly easier. And then I always like to write out the base formula. So I'm doing the cube root of 2 kiss 0 plus 2 pi k all over 3. And then I'm a big fan of just simplifying this inside. It's just going to be 2 pi over 3 k. So now I'm going to do k equals 0, k equals 1, and k equals 2. So all of them have this cube root of 2, so I'm just going to write that. All of them have kiss, so I'll just write that. And they have that opening parenthesis. And now I'm just going to do this. So if I plug in 0, I get 0. If I plug in 1, I'm going to get 2 pi over 3. If I plug in 2, I will get 4 pi over 3. Now these are all easy angles, so we can rewrite these back into standard form. So this first one would be the cube root of 2, cosine of 0 is 1, sine of 0 is 0. So I'm going to get cube root of 2 plus 0i for the first one. Same exact idea over here. It's just going to get a little bit more complicated. I'm going to use parentheses to make life easier. Cosine of a 2 pi over 3, that's going to be a negative 1/2 plus a positive square root of 3 over 2i. And we would just distribute that cube root of 2 in there. Same thing for the last one. We'd have the cube root, that's a giant 3 for a cube root. Cube root, oh, it's so messy. Oh my goodness. Cube root of 2, and then this will be negative 1/2 minus the square root of 3 over 2i. And these would be the 4 answers for 2a. 2b is a pain in the butt because while this gives us a nice radius, it does not give us a nice angle. So we're going to have a 3, 4, 5 right triangle. If I rewrite this in trig form, it's going to be 5 kiss some crazy decimal. 5.36 radians is what I got. So I'm just going to apply the formula, and I'm going to use my calculator off on the side to try to do a lot of the math for us here. But if I do this, I'm going to have the cube root of 5 kiss 5.36 plus 2 pi k all over 3. So when k equals 0, k equals 1, and k equals 2, we can just have cube root of 5 for all of them, cube root of 5, cube root of 5, kiss for all of them. You getting the pattern yet? All right, so first one is just going to be whatever 5.36 divided by 3 is. So I did that off on the side, that's 1.79. Next one, I'm going to do 5.36 plus 2 pi divided by 3, that's going to be 3.88. And next I will do 5.36 plus 4 pi over 3, and that's going to be 5.97. And these are going to be the 3 answers because these are not special angles. All right, for 3a, we're being asked to find the fifth root of these complex numbers. So this is going to be the fifth root of 1 kiss pi plus 2 pi k all over 5. This is already simplified. I don't need to do anything more to it. I'll have k equals 0, k equals 1, k equals 2, k equals 3, and k equals 4. And that gives me all 5 numbers that I'm going to need here. So remember, for the fifth root, there's 5 answers. They all have a radius of the fifth root of 1, which is just 1. So I can just start off by writing kiss for all of these with some parentheses here. Now I'm just going to basically start off with pi over 5. Okay, so pi over 5. And then I'm just going to add 2 each time. So this will be 3 pi over 5. This one will be 6. That's not how you add 5. Sorry. 3 pi plus 2 pi is 5 pi over 5, so that's just pi. Then we'll have 7 pi over 5, and then we'll have 9 pi over 5. And these are not special angles, even though one of them is, the rest of them aren't, so we leave our answers written like this. For 2i, the first thing we need to do is just figure out what this is in trig form. So 2i is way up here, radius of 2, angle of pi over 2. So I can rewrite this as 2 kiss pi over 2. And now I'm being asked to do the fifth root, so I'll have the fifth root of 2 kiss pi over 2 plus 2 pi k all over 5. And I'm going to simplify this inside angle here. This is going to become pi over 10, pi over 2 divided by 5. And then, again, I like to maintain the ratio. So 2 pi over 5, the ratio will be 4 pi over 10 k. So now I can just focus on adding 4 pi each time that I increase the k value. Okay, so we'll do k equals 0, k equals 1, k equals 2, k equals 3, and k equals 4. Boom, 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 boom. They all have this fifth root of 2, so I'll just start off by writing the fifth root of 2. Riveting content that you're watching right now, by the way. I hope you are just glued to your computer screen or your phone screen, whatever you're watching this on. Next, we got pi over 10. Then I'm going to just add a 4 to that, so that's going to be 5 pi over 10, so that's pi over 2. From 5, I add 4, that's going to be 9 pi over 10. Add another 5, that's 13 pi over 10. Add another 4, that's 17 pi over 10, and these are the answers. Even though one of them can be simplified, we don't because the rest of them can't easily be simplified. For a, we're being asked to find the fourth root of 1 plus I. So let's try to figure this thing out here. We're going to first just, I would suggest we graph it so I can see that that's going to be square root of 2 and a 45. So in trig form, this is the square root of 2 kiss pi over 4. Now I'll just apply the property for doing the nth root. So that's going to be 4 square roots of 2 kiss pi over 4 plus 2 pi k all over 4. And you know me, I like to simplify this inside. It's going to be pi over 16 plus 8 pi over 16k. And let's see, I'm going to have k equals 0, k equals 1, k equals 2, and k equals 3. All of them have this fourth root of 2 here. So I'll just write the fourth root of 2 8 million times. They all have kiss. And then we start off here. First one's going to have pi over 16. So I have pi over 16. Then I'm going to add 8. So that'll be 9 pi over 16. Add 8 again, that's 17 pi over 16. Add 8 again, that's 25 pi over 16. And these are the 4 answers. 4b wants us to find the sixth roots of negative 2i. So first thing I'm going to do is just graph that and rewrite this. This is going to be 2 kiss 3 pi over 2. So it has a radius of 2, and it's going in the direction of 3 pi over 2. Now I just follow the formula. I'm going to do the sixth root of 2 kiss 3 pi over 2 plus 2 pi k all over 6. And then I will simplify this inside angle. It's going to be 3 pi over 12 plus 4 pi over 12k. And then I will have k equals 0, k equals 1, k equals 2, k equals 3, k equals 4, and k equals 5. Woo! So many. All right, they all have that 6 square root of 2, so I'll start off by writing that for every single one of them. 6 square roots of 2, 6 square roots of 2. Whew. kiss, 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 do, 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 do. Parentheses. Start off. 3 pi over 12. Can I actually reduce this? It might be nicer if I did that, potentially. But only if they reduce to nice values, would they? This is going to be pi over 4, and this would be pi over 3. So they won't reduce nicely for me to combine them. So let's leave them the way they are. But I can reduce as I go. This is going to become pi over 4. Next one's going to be 7 pi over 12. Then I'm just going to keep adding 4 to that. So 7 is going to be 11 pi over 12. Add 4 is 15 pi over 12. 19 pi over 12. And then 23 pi over 12. And these are my answers. Even though one of them can be simplified, I don't bother. Actually, 2 of them can. Sorry, I missed that this one is actually 5 pi over 4. Yeah. So even though 2 of them can be simplified, we still leave them the way they are because they can't all be simplified. 5a wants us to do the cube root of unity and rewrite our answers in standard form. So a plus bi. So first thing is this square root of unity. So we just need to remember unity means 1 plus 0i by definition. That's what it is. So that is a radius of 1 with an angle of 0. So it's 1 kiss 0, or just kiss 0. Applying the rule for cube roots over here, I'm going to have the cube root of 1 kiss 0 plus 2 pi k all over 3, which is just 2 pi over 3k. So I'll have k equals 0, k equals 1, and k equals 2. That gives me the 3 cube roots that I'm going to need. Cube root of 1 is 1, so I'll just start off with 1 kiss for all of these. If I plug in 0, I'm going to get 0. Plug in 1, 2 pi over 3. Plug in 2, I will get 4 pi over 3. So we have 2 ways of doing these. You can graph them and try to recognize the triangles, or you could just actually evaluate cosine and sine of each one of these. Cosine of 0 is 1, sine of 0 is 0, so I get 1 plus 0i. Cosine of 2 pi over 3 is a negative 1/2. Sine of 2 pi over 3 is a square root of 3 over 2 positive. Here it is still 60, so I'll have the same numbers. Both will be negative because it's in the third quadrant. So these are going to be the 3 different answers. 5b wants us to do the 6th root of unity. So again, unity is 1 plus 0i, so that's 1 kiss 0. So I'm just going to follow the formula. I'll have the 6th root of 1 kiss 0 plus 2 pi k all over 6. So that inside bit there, that reduces to just pi over 3k is what we're going up by. So now I'll have k equals 0, k equals 1, k equals 2, 3, 4, and 5. Don't need to go all the way to 6 because we started at 0. Let's see, 6th root of 1, that's always going to be 1, so then we get kiss, 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 kiss. So many of these. Okay, then I'm going to have 0, pi over 3. This one will be 2 pi over 3. This one will be at pi. Then we have 4 pi over 3 and 5 pi over 3. So we can reduce all these by, again, just evaluating or graphing them. So let me show you the graphing one because I didn't do that last time. If I were to graph all of these things here, I have here, 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 and they're all 60 degrees away from each other. So that's kind of neat, right? The 6th root, we took 360 divided by 6. For the cube roots of unity, we took 360 divided by 3, and we got 120. All of those were 120 away from each other. So we actually didn't need to do all the work. We could just follow the pattern, which is why these cube roots of unity or 6th root of unity or any roots of unity are super fun and easy because we can just directly connect them back to 360 and how much they have. So if we start with this first one, that's going to be when k equals 0, and then we just travel around the circle in order. So this is going to be 1 plus 0i. Here, this is going to be 60, so that's going to be a positive 1/2 plus square root of 3 over 2i. These guys have the same x and y values, except that the x value will be negative when we're in the second quadrant, so I don't need to do any math. Over here, this is going to be negative 1 plus 0i. Down here, these have the same x and y values because they form that little, I guess we would call it like a bow tie or the butterfly or whatever. I have no idea what we called it way back in the day, but they have the exact same values except the signs are potentially different. So we're negative in the third quadrant, and then we are positive negative in the fourth quadrant. So these are the 6 different answers for the 6th root of unity. Direct connection back to the unit circle, and just saying 6th roots, we could just take 360 and divide it by 6, which makes sense because 2 pi is 360. So we're really just saying take 360 divided by 6, and that's how far apart each one is.